Hello, good morning, everyone.
Good morning.
Hope you're fine today.
Yes, please, yourself.
I am fine. So, welcome, everyone. Today is scheduled for computer vision and agentic AI. So, at the end of the day, you should now be able to decide or tell if the who is this person? At the end of today, you should be able to decide if the solution you are designing for should be utilizing computer vision and or agentic AI. To lead today's session, we have two sessions. For the morning session, we have Professor Justice Apati. Prof. Apati,
Hi.
okay, thank you very much for joining us. So I'll hand you over to the teams and then you do your thing. Thank you very much.
Thank you too. I'm not sure if I'm a presenter to at least share my screen.
Yes, you should be able. Please
Okay.
check.
Yes, I've seen it now.
Thank you.
Okay. Yeah. So I'll show my face a little bit to you and then I'll put it off. So I am Justice, as the MC just mentioned, and I am the Department of Computer Science and mostly responsible for anything machine learning or AI at a higher level, but more precisely of optimization, how to optimize models, build models, design models. By looking at the mass bit of it, that's what I normally kind of do. So that's a little bit about me, and I'll be taking you through the computer vision aspect. Okay, so I'll share my screen in a short while and then we'll take it from there as well. Okay. Um, okay, I hope my screen is visible. If you can see my screen, then we'll be able to start. Okay, thanks for the thumbs up. Thank you. Okay, so once again, I welcome everyone to today's meeting. We are hoping to have a very exciting session for today. The slide, as usual, we made available to the desk, and then you can pick them up as the rules are. For today's section, you and I will be looking at computer vision and agentic AI. But I will handle the computer vision aspect, and my colleague will take care of the agentic AI aspect in the evening. I'm not quite sure what his case study will be, but my case study for today's meeting, precisely this morning, will be around the fintech section. Of course, you can feel free and then apply them in any other domain, but I'm only focusing on the fintech as a case study for today's meeting. The content will be a bit brief in quote and in this context. Now, almost everything around us, you and I can perceive it. Because you can perceive it, we are able to interpret it. Because we're able to interpret it, we are able to act on it. This is how the human life actually flows in all aspects of our journey, whether voluntarily or involuntarily. This is how we are able to navigate in every complex space we find ourselves, which means that computer vision cannot be in isolation. It works with other components. I'm sure you enjoyed yesterday's meeting, and I'm sure you'll be enjoying tomorrow's meeting as well. And you realize that they all have to come together to be able to form a very complete system. Okay, as mentioned earlier on, the focus will be more on the fintech as a case study. But at the end of the day, we aren't only interested in building solutions. It's for some people. There should be a target. There should be a reason why you are designing the application. And in this context, it's about accessibility. Of what's relevant is your application to me if I can't use it without an internet? Of what use is your app to me if I can't read? And so your target is very important. And for that reason, accessibility comes in different forms. And I'll explain something to you shortly and realize that almost all of us, one way or the other, have some form of disability, but we don't really regard them. For that reason, it's seen as part of us and normal to us. Okay, so at the end of the day, it might be deployed. Deployed to who? And for what purpose? And how should it be used? All these things come together, which means that at the core of the mission, there are other things you must pay attention to, which most often as developers, as engineers, we hardly treat them as the last thing. So why do we think we should put in inclusiveness in the first place? I know a lot have been said yesterday, so I'll not go into that aspect, but I'll tailor it to the vision point of view. As mentioned earlier on, almost all of us have some form of disability, but we don't really think it is disability to us. All because it feels normal and it feels okay to us. We are all young, having all our eyes clear. Of course, there are some few who have to put on some spectacles at a very young age, but most of us, most likely, began using spectacles sometimes around 2 years minimum upward. And so what looks easy to you doesn't mean it's easy for everyone. This is why inclusiveness becomes important. As we age, we lose our lenses. And so most of us now turn on our phones and put on a very high font to be able to read. That's a visual barrier to us. I have to shout for you to be able to hear a bit of it. Even that one, I have to complement with writing. Hearing comes in. Now, you've given me something in a different language and I cannot read what it is. This is also an issue of accessibility. But of course, you may end up saying in quotes, of course, if you go deeply, people have different definitions for it. The fact I cannot read your language is a problem for me. But I may think it's okay if I can't speak your language or read your language. But the argument is, if I'm living in your community, then I'll find myself handicapped within. Then there, I can now classify myself among the people who need help to be able to move from there. The language part, tomorrow's meeting, I'm sure they'll handle it, and I'll take care of the visual aspect. The visual aspect. So let's see what you and I intend to do for today. As mentioned earlier, computer vision is very broad, but very small. We'll not be doing the classroom type of computer vision here, where we look at the math behind it, how to calculate something here, define this here, put this here, and we'll not be doing that part. We'll be looking at the tools you need to be able to move your way through. That's the purpose of today's meeting. And so you realize that the computer vision itself, in terms of context to the hackathon, is a very small piece. It's a very small piece. But what is it that you must know about computer vision? So the core idea is what you and I would like to pay attention to. And the focus here, again, is in the fintech domain. So it says from seeing to acting. As I said earlier on, all of us have the eye to see, to perceive, observe what is around our environment. As you observe, make meaning from what you see. And so, how then do we empower? Okay. How then do we empower? There's an echo in it. Okay. Oh, sorry. How then do we empower the computer to also see? This is where the idea of computer vision comes to play. In a typical classroom setting, what I will do is, oh, my pen is misbehaving today. Oh, it's unfortunate. Okay. What I'll do is I'll just do something this way. And I ask the class, what is it? Immediately, they'll say a fish. And I'll tell them, on which earth did you see a fish looking this way? However, everyone here by default will say it's a fish I've drawn on the board or on your screen. But who told you a fish is like this? Who have seen a 2D fish before? A fish can be modeled as a 3D visual, but we can't really see 3D technically, even though we perceive or assume we can see it. That's more of projections. We'll not be going to that space, unfortunately. Now, it's because you and I have observed something that looks like this and is so unique to us on Earth. For that reason, the human eye perceives anything that looks this way as a fish. So a fish, so in our junior high school, in our primary school, we'll start by saying living things. A fish is a living thing. A fish can breathe. It has a fin. All the things we're taught at that level is all about the features of a fish, which means that you never get a fish in your mind or in your brain. You get the features of the fish in your brain. In computing, what is the brain when it comes to vision? So you may think the brain, when it comes to vision, is the hardware. No, it's not. But instead, the features you have over here. So at the point of computer vision, we may say that the feature, we may end up saying feature representation or object representation. That is why, after knowing that this is how the mouth of an organism looks like, the tail of an organism looks like this, then technically your brain will now map and conclude by saying this is a fish. Okay, so as mentioned earlier on, several things came to mind to be able to achieve this. You have to go through this for 10 years, 8 years, depending on how early you're exposed to the things around you. So models are supposed to be able to also do the same thing for us and with us. And what are the models out there? And that's the thing that you and I will be looking through one by one and see what we can do with it. The moment you are able to now make meaning out of what we see with our eyes, we can then reason through it. So if it's a fish, the one reasoning could be that you can consume it. If it's alive, you can grow it. So the reasoning comes in and they cannot go ahead and act on it. The acting will not be you eating it. So what do we mean by acting in this space? And that's where the second meeting will take us to, being the 4 o'clock to 6 o'clock. So I'll focus my attention on the first 3 blocks. And then my colleague will do the last 2 blocks. So that's what in general you have here as 4 hours. Section 1 being this section, and section 2 being the 4 to 6 o'clock meeting. Okay, so we've been able to empower the computer to see is all about computer vision, nothing more. This is why I mentioned earlier on that we have to scope it to a space. In that way, we are able to now understand and appreciate how these things work and where they are applicable, and then their failure points. The failure point in your case becomes something much more versatile. Why? Why? Because the context here is accessibility, not just a solution. And so there'll be several failure points. And many always say that your AI will be tested and proven only when it's deployed. At the point of deployment, you realize that your model can do nothing. So here's our journey. What can your eye do? It can perceive. As it perceives, what comes to it? I can perceive by reading. I can perceive by a location, that position. I can perceive to deduce understanding. I can perceive to verify. And I can perceive to act. So again, in this block, we'll be doing the first 4 blocks. The acting, anything acting, move into agentic. So take note of that for me as well. Okay, so what does your model support? Again, the failure point. Why do we need it in the first place? So I'm dealing with people cannot see. For that reason, of what relevance is text to them? Of relevance is pictures to them? They just cannot see. However, they can speak. They can hear. For that reason, you don't expect them to see, to deduce, but rather you consider a visual, how should I put that statement? Maybe a voice prompt to support them, because a visual prompt is irrelevant to them. The visual prompts are the text you see on the screen. So here you can read for yourself. Can I read it? You can see for yourself. Start with the user journey, but the blind cannot see. How do you support them in that direction? And so the things you see here, what to call the visual prompt, is irrelevant to the one who cannot see. Again, the information you see here as text only is irrelevant to that market woman who cannot read. We always say market women, the low literacy, but you forget that if you can't read my language, you also have a low literacy as well. And so the word low literacy is contextual. Those will be coming to you tomorrow, and I think Thursday we'll discuss more of such with you, the language models. Now, I'm living in a space where I struggle to even check my email. And yet you are saying that I should be able to move into the cloud and proceed from there. Of what relevance is it to me? In as much as the cloud aspect is not part of vision, it actually informs you to know the type of models to use for such people to be able to join the train and proceed from there as well. So here we are with the vision aspect to support those who cannot see. But I have to be careful not to just assume that only those who cannot see need vision models. No. In today's world, because of how AI has evolved, vision play a critical role in lessening most of our burdens for us, whether you can see or you cannot see. So in this pipeline I'll be giving to you, realize that whether you are illiterate or low literacy, we don't say illiterate anymore, unfortunately. So low literacy, whether you can see or you cannot see, you can now see that vision models play a critical role in your life. Why? Why? Because there are some things that we cannot know and know it all. So I've come to you and I gave you my water bill. And I'm asking you, this water bill I'm giving to you, how much do I truly want? Do I truly own? And I'm using water bill for a reason. If you are privy to how water bill looks like, if you're not careful, you might think they have cheated you. You see several numbers on it, including negatives. And you ask yourself, how do you consume a negative amount of water? A negative doesn't mean that you own them. Most often, they own you if you are doing prepaid. If you are doing postpaid, you are paying ahead of time. This means that if you're not careful, you may end up picking a car and going all the way to a nearby station to argue uselessly, all because you're unable to interpret. Now, in the context of vision and giving an eye to the computer, where is the eye of the computer? The eye of the computer is the camera. Is the camera. The camera perceives for the computer. And now you know the computer is not it's not just a device you have in your hand. POS are now computers. I can even call my phone a computer. I can call a vending machine a computer. And for that reason, that's the context in which we are using the word computer. So in short, a device empowered with a camera can take on your vision task for you. Now, I have my eye, which is the camera. What should the eye do? As you can see in the image over here, the eye of the phone is reading a bill. And as part of the bill, as seen on the phone, you could see other things on the table. Some banana and some kind of, pepper or so, with some rubber, which looks a bit whitish, and within it is a black thing. The argument now comes in. What is of interest to me? This way in computer vision, in the classroom settings, we will say the foreground and the background. The foreground is what is of interest to you. The background is what is not useful to you. So on the woman's phone, you could see that he's only capturing the paper on the table. But as she does so, you see two things in the image: the small paper and the big paper. The small one is the foreground. The big one, you can see a little bit of it showing at the top left corner, is called the background. In other computer vision books, you come across the word ROI, the region of interest. So the region of interest is also called the foreground. And so the other things around, which in most cases you hear the word artifact, the word noise, they become the background. And so the things you do not need are called the background. So take note of this carefully. Now, from what we can see in the phone, he has captured a paper onto the phone. The eye has consumed an information into the brain. We will not spend time discussing things like projections, representations, and so forth. They are more out of scope for this meeting. Okay, so now he has gotten his ROI onto the phone. But of what importance is it to her? What does she seek to understand in the paper? Of course, on the paper, there are wordings, there are characters, there are text, and they are being organized in a particular way. And so, how then do we read? Before then, we must first understand where our ROI is, our foreground. This is where the second compartment comes in. We detect, we crop, we enhance. If you're a fan of an iPhone, and sometimes Samsung, When I take a picture of you, the picture may look black, but the moment I intend to save, you see it brighten up before you end up saving. This is the context of an enhancement. And so it checks the quality of your image. If the quality is not sorry, if the quality is not as expected, it enhances it. It enhances it. Now you realize that the enhancement bit requires some idea of computer vision to be able to handle that part. Okay, so I crop. I must first detect. When I detect, I crop. When I crop, I get my ROI or my region of interest or my foreground. By so doing, any other thing around is thrown away. Is the content of the document good enough? If no, I enhance. I enhance. Okay. If you are a student in Eugene, you realize that on the software for the graduation, it now requires you to do biometric verification first. If you don't position your head very well, it wants you until it's able to get your face accurately to capture you. In the olden days, the photo or the photographer will say, tilt your head to the left a bit, raise your head a bit, face me quite well, try to smile. All the things the photo is mentioning, they are prompts for you to get an enhanced image. So take note of how we connect the dots from what you are preview to what the machine is doing. Now, in the text or in the document or the ROI, our text, this is where the OCR comes in, the optical character recognition. Its job is to extract characters from your document and put them together for you. But again, of what importance is that to you? I've taken your meter bill or your water bill and I've scanned it, taken the ROI, pulled out all the information as a text for you. Of what relevance is it? This is where the machine learning models will now come in to explain what it is, what's in there. This is where, again, those who take you to the LLMs will explain to you how to deduce meaning from what is being generated from the OCR. But I still can see. For that reason, it will now read back to me what's inside the document. And we'll end at the first three compartments. The last two will be handled by, I think that's Mr. Evans' team. They'll continue from there as well. Okay, now I believe you now appreciate what vision is all about. You have the eye, the camera, then you perceive. As you perceive, you detect. As you perceive, you try to crop the content mentally, especially in a crowd. Okay, that's it in terms of crowd. In terms of documents, we don't just scan everything, we put the relevant information. So indirectly, our mental model, our brain model, which we call the AI engine, is now mapping all the various texts that's ever seen before and begin to read them out as content for us. Okay, so here is the whole procedure I've already explained to you in the previous section. We take the bill or the receipt, pull out all the characters. When we are done, we structure it. For the structure you see here, the relevant information in there for you as a bill is the amount, when due, the account to pay into, and the one who gave you the bill. Now, so who determines this information? Is the engineer, is you. Listen to me today. You determine what you want to give to the end user? Of what relevance are they? So this is where the LLM guy will come in, and he will now say, he cannot say amount 420. This is where screen readers are different from LLMs. Screen readers. For a screen reader, all you hear is amount, GAC 420.50, due date, 12 September. Yeah, this is how it all began. And now you not hear that anymore. You rather will hear something like, the amount I see in there is 420.50 cedis, which happens to be due on 12 September, a year will follow. And the account to which is being credited to is 004 and the issuer. And again, this is where Mr. Evans' team will take you through. How do you model that part? So we'll end at this point by giving you the information. How do we communicate the information to the end user? And that's what you have written here. Okay. Now, this is where, as an engineer, you ask yourself several questions. For every AI engineer, you think more of a failure point than a success point. In this context, what can be our failure point? I cannot see, or I can see, all right, but I can't interpret. At the same time, too, I have an issue with holding objects. So as I hold, I tend to shake a bit. A very common character among our colleagues who unfortunately are addicted to alcohol over time. So he takes the phone, take a snapshot, and he's even shaking already. As he shakes, it blurs the image. Sometimes, to subconsciously, we also shake. And so as we shake, it's blurred. Also, even though subconsciously we are okay, the device we are using, its camera, is not good enough. And so it introduces blurriness to it. So in all this context, I've given you different type of accessibility needs or inclusiveness. I can see, I can't interpret. I can see, I can't interpret, but I'm shaking. I can see, I can't interpret, but I don't have a good phone. These are the type of people you'll be interfacing with. And so your failure point is blurriness. And what introduces blurriness, you don't care to know. All you care to know is that there's a possibility of failing on a blurred image. There's something I struggle a lot. I'm not a fan of photography. And so when people ask me for my photo, I now begin to look for a dress. And then sadly, they ask me for my photo usually in the afternoon or in the evening, right? So when they ask my picture, and I have a white background in my residence, I'll go to it and then take a picture with it. You most often will see a shadow inside. How do you handle that? And the shadow, depending on its intensity, can also erode the information on your paper. Finally, the paper I'm giving to you is being kept in a very close place, tight. Over time, its content are kind of losing its information. It's like a pencil on a white paper. Give it just some few months, go back to it again. It's as if you haven't written on it yet. You can try it and see. So we always will say use an ink to write, which will stick to the paper. But I've written this on paper with pencil for some time. And it's an evidence for you to discover something. Do you throw it away? The answer is no. you should be able to get it out and proceed. At this point, I'll now share a story of how this vision thing became very part of me. I was there when a certain country's prison officers called. I was introduced to them, and the whole idea was that they have spotted someone who they think have come to Ghana, but have made some criminal cases in their country. All they have about the person is a current image after they've arrested him and his JSS or the junior high school picture. Even that one was from WAEC. So I'm talking about an African country. So if you know of which country does more of the WAEC, you can begin to look into that space and which country is possible to have come to us. How then are we able to now map that old picture and let the person in the picture grow virtually to become like that person and end up saying that this is the person or not? This is a typical vision problem. How do you address it? Okay, we don't have the whole time, so let's continue and see how these things truly work in practice. They are not science fiction, they are things currently being done. Okay, so here's a failure point to look into. This is the only way your solution can sell in the hackathon. What failure points have you addressed? Because at the end of the day, it's inclusiveness, accessibility. How do you target all the failure points in there? And how do you even discover them? This is why they always say that get someone who's experiencing that on your team. So you are able to deduce first-hand information from their use case and proceed from there as well. So what are the techniques involved when it comes to CV? What are they? So we have 3 columns here: the technique to look into, the fintech use, the inclusion value. So indirectly, you are doing proposition of value of what relevance would that be to your application. Now, I'm very particular and careful in choosing my words here because it has always been the case that at the end of giving students or participants some idea of vision, they begin to amass all this knowledge and technique together in their work, forgetting about the users. At the end, you'll be done, but you cannot trade the solution. You can't trade it. The first technique you and I need in this domain of CV is the OCR. In the OCR, of what use is it to us? We just saw a scenario to read our bills, receipt, statement, anything that have characters in them. We need an OCR to make it work. And I have a story there which unfortunately I couldn't resolve. In my home, it's a camera. And then there's one man in my community who sells polytank. In the polytank is a Rambo polytank, and there are several types of the Rambos. Then someone ordered for a Rambo 2000 on the biggest polytank. He hardly sell those polytanks. He sell 500 to 15, 750. And he brought his 2000 for them to sell to this man. The night before he could sell the polytank, it was stolen. It was stolen with a clear card. So they came to me because they checked all the cameras. They went to all the houses for all the cameras for their feed. Unfortunately, the person didn't pass in front of my home, so I couldn't have seen the car move. So I told the person there's no car passing through my road at that time. So luckily we got one washing bay who could capture it. And unfortunately, it's as if the guy knew there's a camera there, and the speed at which he ran through that camera. Unfortunately, the camera was a motion camera. So by the time the camera could turn, it creates what you call the panorama. The panorama. A gist of a panorama in the context of voice is like an echo. Something like justice. You hear justice. So in this context of an image, you see like a blurry, continuous image coming in. That's a typical panorama which occurred on that day. Unfortunately, I tried all I could, but I could only retrieve the first two characters as ER. But the relevant thing was the numbers, and the numbers were extremely distorted. So we couldn't have helped the man to retrieve his polytank, unfortunately. So this is a failure point to us. This is a car number we need to retrieve, OCR, but we failed. Now, in this meeting, being fintech, what relevance is the OCR to us? One, visual support and literary support. Because at the end of the day, if I can extract, then I can read to the end user. The next one is the detection of objects. Object detection, which is very, very important. In my communication, I mentioned to you the ROI, the region of interest. This is where the detection becomes important. You see myself and two other people standing. How do you conclude by saying 3 people were dead? How do you do that? In this context, it is an ID. It is a form. On the form, your face is on it. Take for example DVLA. They've taken your picture to your form and want to validate it. I should be able to tell that this is where your picture is, and your picture and the company's logo are different. I should not end up confusing myself by saying that the logo of the company is my picture. This is where the idea of detection becomes important. Now, in this context, this is where again we can support the blind who cannot see. I give the blind a form to fill. He can't fill it. This algorithm can first, don't forget, behind the OCR is detection of objects. The objects are mostly the frames. The frames are mostly the rows, which contains the text and the fill out. For example, surname is a space, either on the side or below it. Other name, either on the side or below it. So behind the OCR, we have the object detection, which detects the fields and then separate the fields from the characters. It can then echo to me, what is your surname? Which in actual sense, we saw only surname. Then the LLM will come and tell us, what is your surname? So it picks the context surname and apply the other thing you'll be learning to it and ask a question. What is your? Then the OCR will come in, surname. Then you now voice out and say maybe Appati. If it's a new name to it, then it may want to ask you, do you mean this? And attempt to spell it. Then you say no. So an OCR occurred before what you will learn on Thursday, Friday, or pick it up and move back again. And so treat what we are doing as a continuous flow. Otherwise, you'll miss the process. There's a space for OCR. There's a space for CV, a space for agentic, a space for language. And together, they help us solve the issue of inclusiveness. So I've given you where the object comes in and how it ties with the OCR. Once that happens, then again, the understanding of the document. What does the fields really mean? What are they? How do you filter that information? And don't forget, the intention is to help your cognitives without overburdening you. Unfortunately, today you hear a lot about mental health conditions and so on and so forth. We, a little bit grown ones, will say the youth are lazy. They can't keep information for long. But the issue is generation and generation change over time. And so it would be unfair for me to say the young are not willing to learn, because their first 15, 18 years of their life, they have lived a certain life, which is more of dependence. And I believe my senior colleagues also say I'm also being lazy, because at their days, news are being read once the whole day. In my days, it was read morning, afternoon, and evening. In your days, it's being recorded. And so even if you miss it, you can go and listen. The young ones coming can't even listen. They want summary. They want summary or the same information. And so, generational wise, the more we move, the more we think that we went to a much harder world than our juniors are facing. So, how then do we resolve those problems? We don't throw them off, but we support them. And how do we? While speaking, I mentioned about the idea of filling my form, which in the banking sector, you hear the word KYC, know your client, know your client. And people are now making some good money out of it as I speak to you. So they integrate with other models, national models. You bring your face, they capture your face, they now use your face to retrieve all information about you. Where you live, your surname, your mother's name, your father's name, how many kids you have. And these are the information we need to fill maybe your bank form. So simply by your face, I can now fill your form without you stressing, especially if you are filling a bank form in commercial bank or eco bank. If you know what I'm talking about, you can feel stressed sometimes because there are too many things they are requiring you to fill. And I don't know about now, but at least for some years back, it takes like a lot of energy. Sometimes you bring it home, come and fill a part and continue. Those of you who also have siblings at home and you go to Montessori, the form they ask you to fill for your child is like a whole textbook to fill. So imagine, for example, my kids have their faces in NIA database or a national database, a very common thing in the West. We want to also adopt over here. So you take my picture, I just take the phone, put it in front of my child, capture the face, and then they are filled. All that information they need maybe about the parents life, I'll show it to my face as well. And I capture the rest, which means 2 snapshots, I'm able to fill a whole KYC, which requires like 2 days to fill. No mistakes. And so it reduced the issue of the manual review. I submit it once and I'm done. It ends there. This same CV can lead us into anomaly detection. Now, there's a behavior everyone puts together or puts up. You can start looking into it. anyone who receives money behave in a particular way. So, as a lecturer, if I'm being paid my salary today, what are the basic things I end up doing? Okay, they've paid me today. So quickly, I send maybe 50 Ghana to my dad, 40 Ghana to my mom, 60 to my brother, 80 to my brother-in-law, 20 to my daughter, 80 to my maybe cousins. I've been doing this for the past 1 year, which means you have 12-month data about me. And you know that my account only receives 2,000 cedis a month. And by the time I'll be done doing all this, I have, say, 100 Ghana to survive on for the month. Then all of a sudden, 10,000 dropped into my account, which is way above the traditional 2,000 I receive as a salary. Immediately, you have to trigger an alarm. Some kind of fraud must have happened using the bank statement. So a pattern had been observed. The pattern observed came from the vision model. And the vision model here we are looking at is the OCR behind the scene. And some models were generated. So the anomaly here actually is the ML aspect of the vision. It goes through all the procedures and it triggers. I'm not quite sure how the banks are doing it at the moment under the AML, the anti-money laundering policy. I've read through. I'm not sure how it's been engineered in our banks. But something happened, and I feel like probably something is not done well. So it was, I think, last 4 years back in Kumasi. I go to the bank. I've received several money into my account, and I have to use the money to execute some projects in Kumasi. I just go to the bank, and then I was told to see the manager. When I entered, they locked the door. I was like, really? For what purpose? Not knowing I'm being suspected of money laundering. So they took me to my account, and I asked them, at the time, I was then a doctor, so I told them, so you are claiming that I could have received some amount of money in my account in my profession? Then they start to sit up. It's like, oh, then they start saying, oh, they are sorry, they are this, they are that, they are this, they are that, talking plenty, and I was let to go. What does it mean? It simply means that my account has received an irregular pattern, which the current AML model treats as anomaly. That's why currently in the banks, they ask you all sorts of income to be declared. And that also helps the model to know that there are days that your account may misbehave, not because you are cheating, not because you yourself are also misbehaving. But now the critical point now comes in. What if in that critical zone I actually misbehaved? How do you tell? This is where your model should focus on as well. The last part here is what we call the vision language model. The vision language model. The vision, the I, the language, the communication. And so I have the I to perceive, but I want the model to tell me what I want to know, not what it wants to tell me. So I start by saying, can you tell me what I see or what it is in this image? That prompt is a language part. The vision is the image. So I'll give you an image, and I'll give you a prompt. The prompt will guide what you intend to see in the image. So the model is being guided to go into the image and extract just as you have instructed it and not being generic. And so I am blind, I cannot see, and I'm walking, I'm navigating. And I have, for example, maybe the town map with me. I upload the town map and I tell the model I am here, I want to go here. That instead of say I am here, I want to move there, is a prompt, a language. The vision is the map, and they navigate with me. Take left, take right, move 4 steps, move that steps, move that steps in that order. Who define the step calibration? This could be a vision thing. That is distance. Distance. You pay that information, you help me out to move. I've given you a bill. Don't just extract. I'm saying that given this bill, can you tell me how much I owe? That prompt is a language which tells the model to go in there and only extract the amount I owe. I cannot see. And then my grandchild comes to me and says, "Oh, Grandpa, they brought you your bill today." And guess what? The child has brought a fake bill to me. So I'll tell the model, I have this bill in front of me. Can you tell me the account number in there? At that point, I am not interested in the amount because I can be taken for granted and be defrauded. And so I ask the model about the account number. It tells me, because I can hear, I synthesize and conclude and say, take it back. I don't need it because it's not my bill. So the vision language model help us to explain the image, and give us the guide as well. So again, those who are in UG, as I said earlier on, if now your registration model or your graduation model now tells you tilt your head this way, your head that way, and this way, it's all because behind it is also some language in there as a prompt beginning to synthesize your visual and saying that no, what you've done is wrong, do it that way instead, or this way. The only thing there is that it only considers who can see, and not telling you that, oh, we cannot see your head well, so do it well. It's written as text. This way again, you can even step it up and now add the voice to it to communicate to those who cannot see but yet want to use the application. This way again, the CV comes in for you. Okay. We'll now proceed to look at the context here. I have already given you the application of the object detection. I've told you if a child in Montessori or someone banking in commercial bank in the days, I don't know about now, and was asked to fill their KYC, know your client. Some say know your customer, whichever way. All I need is my face. Look at what this guy have done. This guy want to fill his form. He has showed the camera to himself. Most likely, he cannot see. He's visually impaired. As you are moving to this space, begin to learn the language very well. I nearly said he is blind. Again, there are several choice of words now to support accessibility. Learn them well so you don't end up using them wrongly. You can't say the person is deaf and dumb. It's a bad word now. He's blind. It's a bad word now. So begin to use the language well since you find yourself in this space. He's visually impaired. And he has put his phone with the assumption that the phone was pointing at him. And guess what? What do you see? You see a green box on his arm. Is it an arm or shoulder or Well, let's assume it's an arm. Okay, the green one, the green border. And then the yellow one is capturing the woman behind. Can you imagine what will happen? If this is a national database, then it simply means that if he's applying for a loan and he does this, he'll end up applying for a loan in the face of the woman. Now, there are two things here, failure points. The failure points could be that the woman is in need of a loan desperately, but didn't know where to go or didn't have the confidence to go to the bank. And the one who cannot see had the confidence to get a loan. And the woman didn't have that confidence, but the face was captured, filled the form, no validation, then we shipped it. At the end, loan had been activated in her name. She'll be quiet, she'll not complain. The reverse is true. When she expects no loan, but was told that he had been approved for a loan, while this man is waiting for 4 days, for 1 month, there's no call, no SMS, nothing, and still waiting. This is where you now come in as a vision expert. He shows the face to the camera, but the face was missed. Proximity has failed. And once proximity has failed, it's clear that the person behind cannot be him. Another failure point, I am a male, but a female was seen in it. Another failure point. And so you tighten up that space and say, it seems I can't see your face. Now, this is where the mistake is. Most vision model will say, I can't see your face. In this case, I can see a face. It's just not my face. A failure point. So your model should be able to see and tell us that, hey, I see a face, but the face doesn't look like you. The face I'm seeing have a camera, an earring, a headgear, and a dress looks more of feminine than masculine. I don't think it's you. Or you can register the face model as part of their phone. And so once I capture, it first goes into my phone model and compare. Again, this is cost. And we'll get there very soon. Do you think what I've said solve the problem or not? If yes, for whom? If no, why not? So this is where you now guide the person. Move your ID closer to the left, to the right, a bit upward. The things that the person would have told you, the model is not telling you. Hold still because you are trying to shake. The lighting is very low, and then capture. It's gone. It's gone. This is where, as a vision expert, you come in. So here's the pipeline. I capture either by camera or by voice, depending on who the person is. And I guide the person by position and lightning. Once I capture, here we are assuming an ID card is being captured. And I extract your face, your name, your country of birth, the things you see on normal ID card. I capture them. And then I come to the liveness, the selfie check. I compare, I move on. I know NIA is currently doing the liveness as well. You will now verify. As a verifier, are you convinced about the person you are dealing with? If yes, we proceed. If no, we hold on. So you can see two things here: inclusiveness and the things you start thinking about if you intend to include vision in your process. So by inclusiveness, you're looking at your audio, the haptic, simple text prompts. These are the things that you want to be looking at. And again, this is not cast in stone and not exhaustive either. It depends on the type of accessibility you are trying to target in your team. At the end of the day, you must demonstrate inclusion as part of a hackathon with user story, and not just model results. I got 90% accurate. And so, of what relevance is your 90% to me if you cannot tell me what I'm going through? The failure points. And I keep mentioning failure points over and over and over because that's what we mostly neglect as developers, as engineers, as designers. So here is the vision stack you want to be looking into. Majority of us are now in the yellow compartment. I'm the last green and yellow compartment. Traditionally, before I began this presentation, I asked, what is this? And I responded, almost everyone will say a fish. What defines a fish? The features. This was the traditional CVs. So the edge of the object looks like a fish. The contour, how Kelvin that place looks like. The tail, how irregular, like an S kind of put together. Immediately, your brain tells you this could be a fish. To what confidence do you have? A threshold is always defined. This threshold, you are responsible for that. And again, back to colleagues and friends and students in Eugene, you may remember when the biometric was rolled out. It was rolled out when you were home. And guess what? Students were capturing their faces as though they were going for beauty contest, and they were just posing, forgetting that it was a passport we're taking, not a context we're doing. And so people were raising their hands. People were in the pub taking picture in the dark. And now that they've come back to school, they want to now log in with that picture. And it tells them, sorry, your face looks like someone I don't know. So quickly, we have to now go in there and redefine the threshold and then flag all such people and allow them to redo it again. As we speak, we have almost over 500 people we have to reverse out of 14,000, out of 12,000 people to reverse. This is where the threshold comes in. We got it right at one point, forgetting that students were not going to obey simple life principles. And so that happened. So quickly, we have to now include the age that says, I don't want more than one object behind you. If I see a flower behind you, I can't capture your face because a flower may look like a child's face. So you do fine-tuning until you get it right. Traditional CV. I'm not saying a traditional CV was implemented. I'm explaining the threshold aspect or the model implemented in that system. Then we went on to the CNN, which happened to be one of the first vision model that came on board. From a deep learning point of view, let me say it that way, which means the traditional ways with the classical approach. We don't want to be going into the theory, so let's reserve it as it is and understand why it's called traditional and proceed from there. Then the convolutional neural networks came on board. And I explained to people in class what CNN really is about in practice, simply by taking a paper, a white paper, and a pen, and I tell the class, there's a game we all play when we're kids. I don't know about today because almost kids of today are living in a self-contained building, and you hardly see the kids playing among themselves except the children and their parents playing. In the days where we have compound houses, then this kind of play is very common. What do? You take your paper, take a coin, put the coin behind the paper, and you start shading. with a pencil. After shading for maybe 10 minutes or 5 minutes, what do you see? You see that whatever is on the coin is actually on the paper. This is a visual understanding of convolution. The process of shading is a convolution. So if you are in the technical aspect of convolution, you observe that you have a kernel and the original image. And the rule says that at the end of convolving, the original image will now have an information about the kernel inside the image. In this place, the kernel is the coin. The white paper is the original image. The operation of the shading is the convolution. At the end of the convolution, I've translated the information on the paper to be part, the information on the coin to be part of the paper. So at the end of every convolution, what you intend to see in the theoretical aspect, a mask could be an edge detector, a feature enhancer, or a feature, what do you know this guy, feature in painting or image in painting. Kernel is there. For that reason, at the end of the day, if the kernel is about edge, if I apply the kernel on your image, at the end of the day, only the edges in your image will come out and leave the rest. This is how convolution works in general. They realize that the models that people are training are so huge, they are so heavy, which cannot support the low resource constrained environment. The idea now is, why not we adopt the parameters and use that to fine-tune a model given a new data? Then the idea of transfer learning came in. So I try to explain this idea of transfer learning to people in a theoretical way by saying, pick your data. Your data was obtained from the sales of maybe iPhones. Today, you sold one iPhone, so you brought in 10 CDs. Tomorrow, you brought in 20. The next day, you brought in 13. Next day, you brought in 14. If you listen to me carefully, you observe that if you plot this data on an X and Y axis, you end up getting an equal increase in days is equal to an equal increase in amount. The difference here is 10, which simply means that from a mass point of view, you have a linear model, which is y equals mx plus c. What you don't know is the m and the c. The m and the c are what you call the parameters. The parameters. In the vision point of view, the c will be called the bias. And then the m will be called the weight. So mostly in AI or in machine learning, people don't call C as part of the weight. But at the mass level, they are all called parameters. In some mass context, the M is called the coefficient, and the C is left as a constant. It depends on which angle you find yourself. From the mass point of view, from the stars point of view, from the engineer point of view, from the CS point of view, from the ML point of view, from the CV point of view, everyone are using different languages, but they mean the same thing. They all mean the same thing. So what are we doing? We are adopting the MNC. We are transferring the MNC. And then we can now go ahead and deploy that MNC and proceed. And so in most models, when you say they have a model, you don't see a functional model. You see a parametric model. A parametric model. And so one of my confusing questions I ask to people will always be, show me your model. And they can't show, all because in their mind they are looking for a function, but in reality they are just numbers. They are not functions, but the function is kind of symbolic, which understands the parameter. Okay, and whilst doing so, then the idea of YOLO now comes in. which happens to be a transfer learner as well, but its intention was to allow us to deploy them on a low resource computers or device. And their purpose are for detection. Then when the idea of all we need is attention came on board, then the idea of vision transformers also became extremely adopted. And today we have all the various models out there being called the transformer models. And I keep on saying, in our current state now, the 2 yellow compartment is what is reigning now. So the traditional vision transformers are looking at the global way of reasoning in an image. So I take an image from different spaces and I begin to make meaning out of those images, that this image has this and that and that in it, and so it interprets and proceed from there as well. And they will now be the vision aspect, add the prompt to it, and become the vision language models. So the image plus a question will now give you an answer. The word question, unfortunately, have been diluted to the word prompt. So it becomes an image plus a prompt implies an answer. So see it from that direction for me. Okay, so here is where we have the vision language model. I give you an image, I give you a prompt. Example of the prompt would then be, what is the amount due? So here the image is the bill. What is the amount due is a prompt. I pick it up, I add them together, and I guide my model. Okay. So I guide the model to be able to tell me the amount due and not everything in there. Of what relevance is that information to me? So probably I can't see, but I can hear. Which warning should I hear? Ping, 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 ping. What does it mean? What is ping, 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 ping? One, intensity. Calibration now comes in. So ping is a warning. It's okay, but be guided. Ping, ping is dangerous. Ping, 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 ping is critical. Calibrations now comes in. You can go audio to speak out and proceed from there. Now, I want to be sure whether whatever is being given to me has no suspicion. So I give you my accounting books to go through. I didn't price accounting. I don't do auditing, but I gave you this particular books. And I'm saying, can you guide me? Can you help me understand what's happening? Is somebody doing something in my name? So I just want to know anything suspicious about a document. Just tell me. So to now begin to take you through. So the document is the image. Okay. I think people are unmuting themselves. Anyway, yeah, that's fine. Yeah. So it takes me through and tell me what is really wrong in there and proceed accordingly, safely. These are the directions you want to go when it comes to the vision and the language. And this will go into the vision. What I've done today, we'll have to also wait on what will happen in the afternoon session, even though it's 4 o'clock, and then tomorrow session. And you see how these two really blend, and you have a very interesting prototype or concept note you intend to give to us. In all of this that I've taught and explained and discussed with you, people are at the center of it all. You are done, that is fine. super good model, that is fine. But because of you, I have to go and buy an iPhone. Really?
Can I know more about you?
And the discussion is becoming too much now. Okay. Because of you, I should buy an iPhone. Really? Galaxy. Really? Then you don't have me in mind. Okay. The next thing is the network. So what I just said was the compute. I need bigger RAM to work. So the failure point here is I have little RAM, a low-end phone. How do you get to me? How do you include me in the process? 2, the network. Because at the end of the day, this looks so fascinating. It will blow you up. If you're not careful, you lose your end users. So at the end of it all, you ask yourself, what are the end users? The end user. And I always use the graduation app to explain some of these things to you. We don't require you to have an expensive phone, but it requires to use at least a device that have a camera on it. It doesn't matter how low the camera looks like. But we didn't consider things like network, because we believe that when students come to campus, they can continue from there. And so they're kind of covered. And we don't have an emergency anyway. And so the use case is perfect. In your case, is it okay to say you don't really care about their network? I don't know. This is where you come in. I never cared about energy. And so whether your battery can take a day or seconds, I don't really care about that. You may care. If you care, how then do you work on the failure plans? Issue of data. I heard some of you talking during the open day about data, how to get data, who will give you data, are you supporting you with data, how large is it? Several questions came up on the open day regarding data. And the convener gave you some nice responses to it. If small, what does it mean to you? Is it biased? And the issue of big and sparse and small and dense becomes important. I have a very large data, 30,000 data, but they are sparse. It's irrelevant. A very small data, but they are very dense. Every single field in there has an information. It's like taking a conco, a container, or a metal, and striking it into a flat object. If I throw that thing at you, I'll hurt you more than throwing the conco itself at you, because it's not being compressed. And if your physics is well understood very well in high school, they know the impact it will have on you if I throw that small thing against you over the bigger form as it was to you. Now, the language. This is where, again, tomorrow's class will take you through. The infrastructure. Will it be on a cloud? If so, the question now is, do you go hybrid or not? So we say that for every AI feature, you should have a failure plan. That should be your design rule. I know they're giving you several rules in your last meeting, that was yesterday, but this is what I have for you as one of the rules to make you sell in the process. Okay. Now, the issue of the edge, the cloud, the hybrid. In all of this, if you go cloud first, then what do you need? The phone, the internet, the cloud, the internet, back to the phone. So I'm going to the phone, hit the internet, enter the cloud, and I'll come back to the internet onto your phone. Is that turnaround time conducive for users? Or you want to go edge first? Your phone, a local model, a result, or hybrid. Phone, local model result. But if I see you in a high resource network environment, then quickly I'll take to the cloud, rebuild a model over there, and download the parameter back to you and stay there. Which means your model always remain active so far as you travel outside your community. It will update for you naturally and get back. Which of the pipelines do you intend to use in terms of the vision model? Because they can be very, very heavy sometimes, depending on how you intend to reason through your process. This is why this triangulated concept is very important. Again, every AI model is tested at the point of deployment. Large models must be quantized, must be pruned, must be distilled. One of the models that you may end up finding yourself or package you find yourself using quite often, the TensorFlow Lite. The TensorFlow Lite, which are more deployable on mobile devices or low resource environments. For that reason, it's easier to deploy them onto your phone. The phone is what we call the edge or the edge device. And so,
Okay.
and all edge devices are mostly low resourced. So they're not meant to be doing processing a lot. Okay. So what is it to understand? And what are your choices? So small can be better for inclusion, and it can reduce the bandwidth and cost and give you a faster response to your assistive tasks. The question now comes in, at what accuracy? At what accuracy? This is where the accuracy now comes in. I always tell my team that don't jubilate with me by saying, I have gotten 95%, 99%. It is one of the useless statements I ever received or I want to receive from my mentees. But we go this route, the failure point. The failure point. The person in Accra, 98%, high-end phone. What do you expect? You can't expect anything bad. Is that your target? Are they your target? Or you want me in the rural area with a low-end phone to also enjoy? Over here, the urbans are green, the rurals are red. Collectively, we are saying we are 95%, which sounds good as though the rural guys are also enjoying 95%. But the reality is that the rural guys are not enjoying what you are predicting or what you are reporting. And so, accessibility design requires subgroup testing in terms of device, disabilities, their language, where they live, their lightning, and the quality of their documents. This is not exhaustive, but these are the things to use to conclude that will your model do well or not. As I told you earlier on, we never thought students will end up raising their hand, go to a pub, and taking pictures poolside and treat them as passport pictures. Yes, so it's a failure point for us. Quickly, we addressed it. So do not underestimate the behavior of your users. They can surprise you unaware. This is why, again, as part of the team composition, we want people who are actually experiencing the condition to help us in the process. So this is the case study to now move on to some few sketches to end today's section. So the pipeline is always going to be like this. You scan, you extract. As you extract, you explain. As you explain, you confirm. As you confirm, you act. The acting part, 4 o'clock, join us to hear that part. The scanning and extract part is what I've taken you through. The explain and confirm is where, again, the afternoon session, as well as tomorrow in the next 2 days will be doing. Collectively, you become much more connected to what flow you want to give to us. Okay, so I'll just run through just this at the last bit, and then we'll look at some of the things I want to jot out down for you. As part of your exercise to think through, not to work out, questions like, what device are we looking at? For those of you who be doing mobile apps, it becomes much more difficult because if you're going for Android, for example, even the type of stack you want to even move in could be a problem. Are you going native, pure native? Could also actually tell you how you intend to deploy. Which device are you targeting? And what OS type are you looking at? What type of guide do you want to give? What data should I leave with you? And which of them should I go to the cloud? Some form of federated. Are they issue of connectivity to consider? As what confidence can I say I have done a good work for my clients or my customers? So in all of this, which are the failure points, you end up having one workflow design, but one failure plan. When this fails, what do you do? When that fails, what do you do? In that order. This is what I intend to give to you, but I haven't told you what to use at what point. And that will be my last topic for today's section. So we are going to look at holistically. These are just white pages. Then we just continue. Yeah, so I'll write it out. I hope my pen will not fail me anyway. So holistically, how do we proceed with all these processes? What tool for what job? I'll call the tools the model. What model for what job? And why? And why? The first one you and I will look at the YOLO. There are versions, YOLO 8, YOLO 11, 9. I think I saw, if not mistaken, 14 somewhere. You can fish it out for yourself. Yeah. So model YOLO. YOLO for what? Object detection, object tracking, and segmentation. 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 Why do you want to go for YOLO? Because one, they are fast. They are fast. They are fast. And also, they can be deployed on edge devices. Edge devices. And so, you want to explore that part if you intend to identify objects, not just identifying them, but also extracting them, segmentation. So, this is the ROI aspect. So, detection, segmentation. Okay. Aside YOLO, what else is there? We also have the ResNet. The ResNet. For what? Classification. Oh, sorry for the spelling. Classification. My pen has failed me today, but that's fine. What else can you use it for? For feature extraction, the edges and all the things I mentioned earlier on to get your feature, which means that you can use ResNet for object representation. Okay. Why do we need ResNet? Because behind it in this context of vision is CNN, which have been upgraded to handle some of these things perfectly for us. And we know CNN are meant for visual task, and the content of the class is computer vision. Okay. What more should we know? The mobile net. The mobile net. For what purpose? The same as what ResNet will do. Same as ResNet. Same as ResNet. But why would someone go for mobile net over RestNet? Is because of edge. They are cheaper to deploy on phones, on microcontrollers, micro devices, and so on. So someone wants to go for mobile net over RestNet. What more efficient net? As the name suggests, if you hear the word net, it seems to be network. Okay. So efficient net. For what purpose? Again, they do classification. For what purpose do I need it? As you can say, what is efficient? And so you are looking at accuracy, as well as computation trade-off. So I'm not too expensive. At the same time, I get the work done. So I'm being efficient. Okay. So all these three happen to be in the same kind of category. Okay. Now, what more? I mentioned object detection. Is that the only one available? Certainly not. You had a DETR available also for object detection. Why will I choose this over YOLO in the first place? I mentioned YOLO is fast, YOLO is for the edge, but this guy happens to be based on transformers. Which today has taken over or taken dominance in the world. But you could see YOLO can do both detection and segmentation. So what other thing can we get for segmentation? Over here, we have for ourselves what we call a sum. Simply meaning segment anything. That's sum. And there are two versions, the sum and sum 2. And their purpose are for image segmentation. But the beauty of this guy is not just image, but also for video. If you plan to do something video, capture a video and analyze. Don't forget, a video is nothing but a series of images defined on time. And so I can take series of your image and tie them to a time, and that's a video. That's why you can resample video into images. And there's no algorithm that processes video directly. They always do sampling. Though the people claim they do video directly, I don't really believe in that personally, because behind the scene, you are doing the analysis on the fly. It doesn't mean you are doing the video itself. You're actually processing the images in the video, which you call the frame. The frame in a normal context is an image. Okay, so you proceed from there. So why would someone choose SAM over the YOLO? I'll give you one information, the video. And secondly, they are meant for general purpose segmentation. It doesn't matter what you are doing. So general purpose segmentation, I can use them and proceed from there as well. But how am I able to convert image to text? The idea of OCR now comes in. One of them to look at the clip. And the clip helps us to understand image to text. So it's able to convert your natural language with visual concepts in it. Aside that, there's something more. Oh, someone is in here again. Okay, the clip. Aside this clip, there's a common one now people have also been exposed to called the dyno. And there are several variants of dyno. The dyno V2, dyno V3, and a traditional dyno called the grounding dyno. And all of these are for visual representation. Remember, I gave you the idea of feature representation or object representation. This visual representation. And these are normally pre-trained models meant for feature extraction in the visuals. Okay. Apart from the clip, we also have what to call the paddle OCR. So let's go to the next page now. So the paddle OCR. And we all know what the OCR can now do for us for extracting characters in a document. We also have one common one. I think almost everyone may know about it if you're into this space, the Tesseract. I think Google also brought it on board and almost everyone jumped onto it. Okay, so these are the techniques I want to leave with you. And so I'll now give you a story in how all of this will be used. And then I'll hand over to the mediator. Okay, so from vision to agentic. How can I particularize this in the context of fintech, accessibility, and considering a low resource environment? How can I? I've given you several information here, but how can I coordinate them in the first place? So I can start by taking my YOLO. And my YOLO will come into the scene because I want to ask a question. And the question is, what object? What object are there in the scene? So YOLO will tell me a person. For example, I can see a person. I can see a car. Name them all the objects. And so YOLO helps me to reduce my burden of asking or knowing what's in there and simply giving me the object I need. You can go ahead and fine-tune it to give you the bounding boxes, the confidence score, why it says it's a person, not a car, and so on and so forth. They are just parameters you have to now put in there to fine-tune them as expected. Okay, now, once I have my YOLO coming on board, I'll now pipe it into the mobile net. So I can ask the question of what is this image? What is this image? That's a question I want to ask. So you can now go ahead and tell me what that image really is about. Okay, and I told you earlier on that the idea of this mobile net came on board to help us deploy them on an edge. After knowing what that image is about, for example, I get to know what objects are in the scene. I can even begin from this being first. What is this image? It is a bill, a water bill. What are the objects in it? A logo, a name, an amount. Can you then extract it? So pedal OCR, which asks a question of what does the document say? What does this document say? So it tells me all the objects in terms of their character because of the question I asked. The question was, what is this? It's a bill. What is inside that bill? A logo, your name, your this, your that, your amount. Can you extract that information to the amount we'll now pull out? Now, if I happen to have different form of information clustered together, then my next question will be the fourth one. Which pixel? And before I proceed, a pixel, the smallest object of an image. Every image is a grade. It's a grade. If you happen to come from a senior high school where we have visual art students, you realize that before they will paint you, this is your actual picture. This is your picture. Before they will paint you, they will take the image and then put a line through it. A line through it. And then they will count how many columns. 1, 2, 3, 4, 5. 1, and then the row 2, 3, 4, 5. I don't want to go into this, but let me just give a brief snap on how the visual art students do it and how that idea became computationalized or computerized. So now do not take it over here. A very big paper. This is a passport picture. And a very big paper, they also do the same counting. So they'll measure the length over here and divide by the number of elements here. So you can see it's much more bigger here. Much more bigger here. Over here, they are small. But what matters is that the same number of column and row. They will now count 1, 2, 3. I see an arc here and an arc here. They will count 1, 2, 3. I see an arc here and an arc here. And then under 2 and 3, I see something here. Then they keep on tracing. By the time they are done, they end up tracing you. These boxes are called a pixel. The pixel. Okay. And by the time they finish tracing, so you don't ask, so which pixel is the human head? The third, it depends on how you're counting. It's counted by RC, row column. It's found in the first row, column 3. Column 3. How do we ask that question? That is sum. The sum asks the question of which pixel belong to the object. And by so doing, you could literally see that I'm discussing segmentation problem. Especially when you have multiple information. You can see me, you can see the moderator, you can see any other person. Which of them is me? This is where the pixel will now begin to align. This is me, this is that person, and that person. At the end, we form segmentation for ourselves. And now proceed with the last question that asks about the clip. The clip. What does clip ask? Clip asks a question of which description best matches the image. This is the question this now asks. And so at the end of the day, I cannot end up tagging whatever I segmented that this is justice. This may be Kwame. This may be Kofi. By tagging them, they now measure the score that comes with it. This is the direction I want us to go into. So in summary, you begin with classification, and by so doing, we have to go through an image. And by the image, we'll end up seeing mobile. When I've seen YOLO, when I've seen SAM, it deals with the image. They now move into the image plus text. In this place, you end up seeing the clip, which I just mentioned, the dino being defined for you over there. And then the evening session will take you to the image plus the agent. This is how far I can engage your audience, and thanks for coming. Over to the moderator.
Thank you very much, Prof. Appati. I was expecting to see a lot of virtual applause. Yes. All right. So we'll use the next 5 or 8 minutes for questions and answers. So please, if you have any question, kindly raise your hand and then I'll call you. So we have Eric. Eric Amankim. Yes, please.
All right, so thank you very much for this insightful session, sir. This is very, very powerful and helpful. So I am Eric Amankim. I'm a user experience and systems engineer at iCreations. And my question is, you emphasize that a model having 90% accuracy doesn't necessarily mean the solution is inclusive. So how do we actually measure inclusion as an engineering metric? For example, if a KYC model performs very, very well overall, but consistently fails for visually impaired users or people in low resource environment, what metrics or evaluation framework would you recommend to prove that the system is genuinely inclusive?
Thank you.
Thank you.
That's a very important question. Okay, do you want to continue with the question again? Do you want to continue something?
Thank you. That's what I said. Yes.
Yeah. Okay. Yeah, thank you. That's a very, very, very important question. And I think I've received this question almost every platform I do, or I mention that particular statement. Yeah, so quantitatively, we don't have a metric available to just say I'm measuring inclusiveness, right? However, this is where we now come in to look at subgroups. The same metric we use as accuracy is the same metric we use on them. Precision, all the things you know that is being found. In class, we say confusion metrics, which produces the accuracy, the recall, the F1 score for you. That same information is being used, but it must be tested on the subgroup to confirm that in this subgroup, this is how it actually behaves in their context. And begin to ask yourself what led to the failure point. The failure point, when being resolved, automatically also scales for those of us already included. Now, take for example, I cannot see, but you give me a phone that only provides text. No problem. When you are training your model, you added me to it to train. Remember that by adding me to your model, I will indirectly influence your percentage badly. Let's come back here. Because of these raw guys, my real percentage is 95% overall, not 98 or 99. Now, who is causing the deficit? The raw guys. You now sublet the raw guys and find out their need. If you solve the issue of the raw guy, you have automatically also solved the urban guy by default. And so I'll flip the coin to the raw guy and reassess the same metric. And by so doing, I will not improve, because I can't improve the high end again, 99, 98, I can't improve. But the raw guys, if each of them can go even 1990, I can hit 97 overall. So that's how I can respond to you. So the question now will be, how then do I identify the failure point, which now translates into an overall accuracy? Thank you.
Thank you. Thank you very much, Prof. That makes a very good sense.
Thank you too for asking.
Okay, we have Gladys Ashram next.
Thank you.
Gladys, are you there?
Yes,
Okay.
I'm here.
All right.
So, Mr. Justice, thank you very much for your submission. It was very insightful. My name is Gladys Ayobia, also from iCreations, and you've shown us how OCR and object detection, vision language models, and agentic AI can work together. But then, in the real fintech environment, where errors can actually have financial and legal consequences, how would you architect the system so that the AI can make decisions while still knowing when it should stop and hand the case over to a human?
Thank you. The question you've asked me is what to call the guardrail. The guardrail. And as an engineer, you are responsible for that guardrail. Right? Now, as developers, there's something I've witnessed in the industry which I'm still fighting most often. If you're an engineer, you're building systems and tools, there are three things you must provision. One, we call it the development stage, the dev stage. I don't want to go into this anyway, but let me just do the dev stage. And then the staging, also the dev environment. Let me see the dev environment, the staging environment, and the production environment. These are the three things we need. Now, let me not tell you what normally happens in the industry, because I've experienced that before coming into academia proper anyway. So, in most of the cases, your MD, your CEO, all he gets is a response, an answer to a client's need. You don't care how you intend to do it. So, most often, most companies don't have this part. You can attest for it for yourself if that's the case in your company. They start from dev into production. All because the client is so much on your neck, forgetting about the dire consequence of it, the implication. Like you said, this is finance, and make a mistake, you are losing all your insurance. All your insurance. I will always recommend that, yes, before you begin to go to production, always move into staging. A staging is a replica of the production. Similar to what we do in AI, what we end up saying, we have the train, and the test. Now, in this train and test, we have the train, and the val. Traditionally, we do this together and deploy here to avoid packing. Again, I don't want to be using these jargons. I want to be very, very low on the jargons. So we have this information. Now, when deep learning came to life, people now forget that there's something called val. They now say train and test. So those who don't know how AI evolved to this point always believe that we only have these two sets available. Why? Because the deep learning consumes this together and do its own CV there. CV here is not about computer vision, it's not about cross validation. Which in the SaaS environment, you call it the bootstrapping. Again, I don't want to go into jargons now. So in your case, this is where we need to come in, stage it, simulate all possible consequences, and tell the system that, hey, these are the potential things you're going to face. But the argument is that you cannot know all failure points in staging if you don't have the full people around. Take, for example, in your company, you only have visually impaired, don't have hearing impaired, or hearing impaired, but we don't have maybe something like Parkinson. And so those failure points will come real in production. For that reason, you include in your production feedback system. And this feedback system should be defined on a threshold. So if you go below a threshold, you feedback a human agent and continue from there. This is how I'll design the pipeline for you, if you're able to follow what I'm trying to put together. Thank you.
Thank you very much.
Okay, please, do we have any other questions? None. I also do not see any in the chat. So, none. Okay. So please, thank you very much, Prof. Appati, for this insightful session. To the teams, I hope you found this valuable. Take note that we are taking you through all of these sessions so that you will end up giving us a better abstract of your proposed projects. this is the technical feasibility of your solution or your project is one of the assessment criteria. So it will not just be enough for you to tell us that you'll be utilizing computer vision. What model are you using? Does the model fit the problem domain or the task or the job in which you are utilizing or adopting that model for? This session would continue this evening at 4 p.m. Please check your emails and join using the appropriate link. Before we call it a day, can we all give